This is House Planning Help episode 64. Hello, I'm Ben Adam Smith, and this is the podcast for you if you're someone who wants to build a house or to retrofit an existing property. I'm exploring what houses we should be building in the 21st century. Alongside this, my personal goal to create an energy efficient home before I turn 40 in August 2016. And in this session, I'm going to be chatting to Ken Levenson from 475 Building Supplies. We'll be talking about overheating. This is a very significant episode too, because, well, this was meant to be happening in about 6 weeks' time. I have some personal news. My son has arrived. So we've been going backwards and forwards to the hospital. He's not out yet, but he's making great progress and he's already such a character and a cutie. So I just feel blessed at the moment. And of course, we're coming up to that stage where I've been producing this podcast for 2 years, and that seems to have coincided with our total downloads of these podcasts is now over 50,000, which is a landmark that I feel I should stand back from and just think, life is good. When you've got those moments, you know what I mean? Life is good. Today's interview is on the topic of overheating. On the whole, I think we all associate low energy buildings with having this great indoor environment with very even heat, comfortable temperature, no cold surfaces. However, on occasions, it can get a little bit too much and it can overheat. And this is not just specifically tied to low energy buildings. It can happen to any building. So we're going to have a chat with Ken Levenson from 475 Building Supplies. And I started by asking him for a bit of background about his career.
Yes, so I'm an architect by training, practicing architect for about 20 years with my own small practice in Brooklyn, New York for about 10 years, at which point I had started digging around for low carbon building solutions, becoming more and more obsessed with climate change, and stumbled upon Passivhaus on the internet and said, well, here it is. Here's finally something that's speaking to the proportionate reductions in energy and carbon demand that we require. And so I quickly was very fortunate in being able to convert some clients and convince them to do passive houses. And essentially the last few projects of my architectural practice were passive house projects. In doing the projects, we found that we were really struggling with some of the materials and with the building supply industry in general. And out of that, working with my business partner, Floris Keverling-Boesman, who's a Dutch-trained architect, we realized that these materials existed in Europe, and we knew of these companies, and we could reach out to them and fill this hole in the marketplace as we saw it existing and growing. So I actually stopped taking architecture jobs, and in the process of closing my office, which is essentially closed at this point, and we started 475 as a startup, basically an e-commerce business where we import most of our products from Europe and Germany in particular and distribute them across the US. And we're very focused on spreading knowledge, providing training, and on-site customer support. So it's very exciting.
How would you describe the passive house movement in America at the moment?
It's still very much in the sort of nascent phase. It's very much just being born and forming. We see projects from coast to coast. We see growing interest, but it is still such a tiny sliver of the market and of the general consciousness. At the same time, we're very excited that professional firms, bigger firms, and we see now real estate interests and governments, particularly local governments, taking notice. So we're very encouraged.
We want to talk specifically about overheating today. So can we start with, how do we define overheating?
Well, Passive House is very specific in how it defines acceptable overheating in a technical manner, which is 10% of the hours of the day would be above 25 degrees centigrade or 77 degrees Fahrenheit. And depending on what your comfort level is, that may be overheating or it may not be. It may be overheating at a lower temperature threshold. From a non-technical and a more environmental point of view, overheating is going to be where the internal temperature of the building is rising to a point where you have discomfort. of the occupants.
And this has happened throughout history in different buildings.
Absolutely. It's nothing new or unique to Passivhaus. I think what's unique to Passivhaus is that they're identifying the problem and being sure that you address it successfully. Most of the buildings that I grew up in some form or another, or have worked in the past, overheated in the summertime months. And it can be any combination of things that are causing the overheating to occur.
Before we get onto the reasons of why they occur, there's no reason why a passive house building should overheat more than a traditionally built building, or would that be wrong?
In the general sense, that is correct. There's absolutely no reason, all things being equal and assuming basic considerations of construction, there's nothing unique to passive house about overheating per se.
So why do buildings overheat?
Well, what happens could be a combination of a couple of things. One, which we readily see, is during the day, in particular in the afternoon, if it's a hot, warm to hot summer day and you have solar heat gains, uncontrolled solar heat gains. Solar heat gains can warm up a space to extremely uncomfortable temperatures, particularly if you have western exposure and you have that long afternoon sun coming in. So that's one way. Another way is just from the thermal envelope from an insulation point of view. If you have a very hot temperature, the heat transfer through the enclosure is going to occur coming into the structure, just like it would be in the wintertime going in the other direction from the inside as a heat loss to the outside. You also have internal heat gains. You know, what people may be identifying, or mistaken identity, if you will, is we use internal heat gains for the winter months, for the heating time of the year, to great benefit in a passive house. Now in the summertime, when we're worried about overheating, the internal heat gains are a huge liability. And so we want to be very careful. So by internal heat gains, I mean everything from our lights, our electronics. In New York, our TV cable boxes are particularly strong heaters. You can practically heat a passive house with your TV cable box. The light fixtures, cooking, the people, the pets, all of this are generating heat continuously in the enclosure. And so you have a heating effect going on, which can contribute significantly to overheating if the space is sort of at the borderline of conditions.
We will have thought about that up front, though, wouldn't we? Considering all of those internal gains combined with the solar heat gains. So we wouldn't necessarily be expecting, I mean, what conditions might it, if we have a party, is that what we're thinking? Lots of people suddenly cram in and you've got all the insulation and the air tightness and the mechanical ventilation system, or what other strategy you're using just can't cope.
Right. That's correct. I mean, when you're designing a passive house and putting the numbers together in the PHPP, you're accounting for the equipment, for the people, for the lights. And with the design in proper balance, you should be very much limiting the overheating to a quote unquote tolerable level, which again, the Passive House Institute's definition for certification is under 10% of the time. Even if you've met that criteria, when you do have a party, when you are baking or cooking significantly indoors beyond, what might be typically associated, or if you have not closed the blinds or done certain things, you could experience overheating. One of the issues is that built into the PHPP and the design of the passive house, to prevent overheating, you have certain boxes that you can check where you are saying you're going to do, nighttime cooling with ventilation, flushing the house or the building during the night when it's cooler out, or through opening the windows or by closing external window shades. And this requires typically the occupants to actively do these things. Now, that's all well and good in the PHPP and the design, and you're getting the result that you want. But in actuality, if the occupants aren't behaving per the design in the PHPP, they could be experiencing much greater incidences of overheating. So this is something to consider as the occupants may change to have a little bit more robust. So we can talk about this in terms of active cooling and how we would deal with it to minimize this sort of unintentional overheating.
Let's take a couple of scenarios now. If you're in a passive house and it's overheating more than that 10%, what can you do?
Well, during the daytime, if the temperature is outside is hotter than it is indoors, you can't really do anything short of turning on air conditioning and actively cooling the space.
Well, you could in somehow shade it externally. That could be a strategy, or not? Are you saying?
Yeah. Well, once you're overheated,
Well, yeah, of course.
you can't get it back. So certainly to prevent the overheating, some basic things that we want to do passively is external shading, whether architectural elements, awnings, or trees, landscaping, or things like shutters that you could actively close or open. So you really want to block the light and the solar gains on the outside of the building. Less preferable, but it can have definitely some beneficial effect, is to have window blinds within the building, but much less effective than external shading. Really important, and this is one of the things we talk about in terms of passive solar strategies in general, although passive houses are not passive solar houses per se. It's much easier to control solar heat gain on the southern exposure. You can much more precisely prevent this direct solar heat gains in the summertime. As we add windows to the east and west facades, it becomes much more difficult to control. So it's not to say that you can't have glazing on the east and west. Certainly you can, but you need to be much more careful about it in terms of external shading. We've definitely had examples of buildings where it's otherwise functioning perfectly well. And I know one example where the family room is facing west. We have these big windows, and the trees outside were providing good shading, but then the trees got either trimmed or cut down, and we had much too great western solar exposure, and that room would overheat in the afternoon and requires the addition of external shading.
I know that, having visited a lot of passive houses, occasionally I will hear someone say that the brise soleils that they have there is very effective, obviously in the summer, and in the winter obviously lets all the solar gains in, but there's a period in between where it's not so effective. Now, is that what you're saying about if perhaps you're slightly off south, or if you're in the other hemisphere the other way around?
Yeah, no, absolutely. Certainly at different times of year with the orientation, you need to be very careful with the sun, especially if you're being relatively aggressive and using it for your energy balance in solar heat gains, to make sure that you are considering the sort of shoulder months between the summer and the winter, when it could be at particularly unique angles where you're going to get the gains. In the shoulder months, though, we can start to look pretty reliably, even in a place like New York, for nighttime flushing and what's called free ventilation, where you're running an exhaust ventilation without, or you're running the ventilation system without heat exchange, and you're bringing in the fresh air at the cooler nighttime temperature. You're lowering the temperature of the interior environment overnight so that the next day it can take on some heat gains without overheating. What we find in the summertime in our environment in New York is that it's often too hot at night. We have times in New York where we could have a week of 38 degrees Celsius, 100 degrees Fahrenheit, and at nighttime it's going down to 30 degrees Celsius. There's no relief overnight, and you have to have air conditioning to provide relief from the heat.
Are there any other strategies as an occupant that we should be aware of, or have we covered those before we move on?
Yeah, well, I think, we mentioned them sort of indirectly. I think that we really want to be cognizant of the internal heat gains is the big one. So to the extent that we have good indirect daylighting, we're keeping the direct solar gains out, but we have nice daylighting and we can keep internal light fixtures off is great. I try to encourage clients to not bake or cook extensively indoors and go use the barbecue in the yard if they have one. And certainly any electronic devices that are running all the time and creating heat, it's much more important to have them shut off in the summertime for comfort reasons than it is in the wintertime when they're actually part of your heating system. So that you really do need to be more cognizant of that. And if there are these passive systems for providing relief, such as exterior shutters or ventilation that has been built into the design of the building, you really need to take note of it and practice per the design, or you're going to be uncomfortable.
We can never blame the insulation and airtightness for this, can we? Because in many ways it should give us that thermal envelope that should be able to shield us from that hot exterior.
Right. That is true. So it is very much the opposite of what we could blame it on. The lack of insulation or air tightness, where you have the heat coming in. It's definitely, that is a case of mistaken identity where people feel that this greater insulation level has caused this overheating to occur, where certainly the insulation is, if you have an airtight environment that's well insulated, a passive house, you are going to hold the cooler temperature indoors in short-term extreme heat events, weather events, longer than a typical building. There's just no doubt about that. There's been many examples cited. In the United States, one case that comes to mind, a house in Virginia where there was a blackout in the summer time a couple of years ago, and the houses around them were all unoccupiable quite quickly after the blackout. And the house, the passive house in the neighborhood in Virginia, not only habitable, but comfortable for many days. So eventually the temperature is going to rise. Unlike in the wintertime, where the passive heat gains are working for you inside, and you can achieve an equilibrium without power sort of indefinitely, if not in a very comfortable state, in a safe and usable temperature range. In the summertime, it will eventually become quite uncomfortable, if not unlivable, depending on how hot it is.
I've got just a couple more questions, and one of them is again down to experience. That places that I have seen overheat generally have been small buildings. So is that just coincidence, or if you have a smaller passive house, it'll be more likely to overheat?
I don't know, to be honest with you. I have a feeling that it may be...
because the incidental gains at that point will become more significant, won't they, in a smaller...
Yeah. I mean, that certainly intuitively makes sense. I don't know. I don't have any deep reading or learning regarding that difference, but it intuitively makes sense.
Well, one more question then. What about climate change? We know that it's starting to make our climate warmer, but could we be in for a shock if, let's say, not 2 degrees, but we end up going 4 degrees more? What will that mean for all these buildings that have almost been programmed to operate at lower temperatures?
Yeah, well, I would say that it was one of the more interesting things from the Passive House conference in Aachen this spring. And at the beginning of the plenary session, the IPC scientist from Budapest, Diana Erga-Vorzatz, who subsequently gave the opening talk at our New York Passive House conference because she was so fantastic, made the key observation. She really drove this home more in New York even than I think she did in Aachen, that our problem at the end of the day is not going to be heating. It's cooling. It's all cooling. And particularly in cities, because what they're showing with the research that's really interesting is that, you know, we all talk about the heat island effect because of the concrete, the materials and such in our urban environments. But a huge factor and a growing factor is going to be the fact that we have to air condition to such extreme amounts all of these buildings. And as we're air conditioning, of course, we're removing the heat from inside and throwing it into the outdoor city environment. So all the buildings are heating the cities. And I don't know the exact implications, but it's certainly the case that at the end of the day, it's going to be a huge cooling problem. And they were saying that the latest IPCC scientific research was saying that by the middle of this century, wide swaths of the United States and Europe, you actually won't be able to work outside during the day in the summertime. We're going to have to move to nighttime work and then wintertime work. And so the overheating is really going to be driving. It's going to be interesting to see how this evolves, where Passivhaus really started from a cold climate heating genesis beginning, but really what I think will drive the conversation, the science, and how we're approaching it is going to be cooling dominated. In New York, we're fortunate where the passive houses are generally where we're driving down the loads. The passive houses are being heated by air-cooled heat pump systems that provide the air conditioning. They can also provide the heating. So very simple technology now and can be used in quite cold climates. And we see, I think there's a growing realization, even not just here, but globally, that these systems are kind of ideally suited in their ability to provide both heating and cooling, and will be flexible going forward to balance this out. So we're excited about that.
Well, Ken, it's been absolutely fantastic to have a chat with you. We always enjoy connecting with different parts of the world, and I think you're our first from New York, so thank you very much for your time.
It's been a pleasure.
The show notes for this episode are at houseplanninghelp.com/64. We've summarised what we've learnt today. We have a few photos, and also we got links to Ken and 475 Building Supply, so go and take a look. My question for you, again, I quite like it sometimes when we share different experiences, so I'm wondering whether you've actually been in a house that has really overheated. It doesn't even necessarily have to be a low energy building, but I'd like to hear about that, and you can do that at the bottom of the show notes. Once again, houseplanninghelp.com/64. My call to action today is that if you found some value from this podcast and the series that we've been doing, please tell a friend, someone who you think might benefit from what we're doing here, and that would be absolutely fantastic. Thank you to you. So looking ahead to next time, and Alan Budden from Eco Design Consultants, he's going to be my guest, and we're looking at the impact of simple design decisions on energy performance. It's going to be a good one. Hope you can join me then. Cheers.